Hello, everyone. All right, so today, Mr. Havel here, we're going to go over 7.5 notes, which is solving rational equations. So we have a couple strategies here for solving these guys, one of which is, you guys have seen before, number one, cross multiplication. Okay, so cross multiplication. So this only works when we have, for example, say that we have 2x over 5 and 5/6. Okay, just making up a couple fractions. One thing I've noticed is make sure we have to have an equal sign in order to cross multiply. If it's just a multiplication sign, remember with fractions, you just multiply the tops and multiply the bottoms. But with an equal sign, you can actually cross multiply. The other thing that we need to know, we'll say must have equal sign to cross multiply. And then number two, it's got to be one fraction on one side and one fraction on the other. Sorry, ran out of space. So one fraction and one fraction. So if you have two fractions on one side and then one on the other, this method doesn't work. Okay, so I'm going to show you this way, but this is kind of the only time I do this method for this chapter. Okay, so cross multiplication means that you're going to multiply that diagonal together. So we're going to do 2x times 6, and then we multiply this other fraction together, or sorry, this other diagonal. So equals 5 times 5. Cool. And so now you multiply it together. This is 25. This side becomes 12x. Divide by 12. And so x is equal to 25 over 12. If you can, reduce it, but in this case, there's nothing that goes into 25 and 12 evenly. Okay, so that would be what x would equal. Now our second method is one that I will show a lot because it works for all of them. Okay, so this step right here where it's one fraction to one fraction, this next process doesn't matter with that. It could be as many fractions as you want. Okay, so the second one is find a common denominator. Denominator. Okay, so the same exact example. So we've got 2x over 5 is equal to 5 over 6. Okay, so if we have this same example, what we're going to do first is we're going to figure out, okay, what is the common denominator between 5 and 6? So if I do that, the common denominator for these two would be, the smallest one would be 30, right? So in order to do that, I'm going to multiply top and bottom by 5, okay, on the right-hand side. And then on the left-hand side, I'm going to multiply top and bottom by 6. If you notice here, you're kind of doing the same thing, right? So on the left here, I've got 6 times 2x. Look what we had up here. On this one, we've got 5 times 5. Holy smokes, we got it there. Okay, and so I'll bring it back over to this side because I ran out of room. So I multiply the top, and I get 12x is equal to, 12x over 30 is equal to the top's 25 times, holy cow, over 30. So when we had talked about this in previous sections, but now with fractions, if you have the denominators being the same, right, so they're the same exact thing, I just need to make the numerators now equal to each other and solve for those. So I can pretty much just drop those denominators because we've made them the same. Now to make the top the same, I do 12x is equal to 25, divide by 12. And holy smokes, it comes out to be exactly the same thing as this guy. Okay? And so this is the method that I will be using a lot. It will make sense when we get on to the second page of the notes. Okay, so just a reminder, okay, rational expressions, so these beautiful fraction guys, cannot equal 0 in the denominator. Okay, so numerator, we don't care. It's just in the bottom, the denominator, we do not want it to equal 0. Okay, so it says any value of x that would cause it to go to 0 is part of our domain restrictions. Okay. So as we go through here, the first thing I like to do is, I'll kind of make little notes here. Number 1, I like to grab my domain. Okay, maybe before I write that, you're not going to see this a whole lot, but sometimes factor, I'm going to say factor denominator if needed. Okay, so you don't always have to, but you will have a few problems where you do need to factor that denominator. Then we're going to grab our domain. Okay. So let's pause right there and go to number 1. So here, the nice thing is this denominator and that denominator are already factored, so I don't need to do anything with it. I can go exactly to step number 2. So on 2, my domain restrictions would be x cannot equal. We have to solve each one. So if I put this x is plus 3 is equal to 0, minus 3, so x cannot equal negative 3. So cannot equal negative 3. And same thing here, x minus 1 equals 0. Add over the 1, so x cannot equal 1. Cool. So those are my 2 domain restrictions. So those are the 2 values I get. So what happens is you're going to solve it, and then if I get to the end and they tell me that one of these 2 is the answer, we go, no, we can't have that. So we have to cross it out. Okay? So then our next step, number 3, we'll say common denominators. Denominators. And so the really nice part about this is we're not going to be super cruel to you and give you a super ugly denominator. Usually you're just multiplying everything by 1, maybe 2 things, right? And so here you have to look at these as entire terms here. Okay, so it's an x plus 3 and an x minus 1. So unfortunately on this left-hand side, I can't just subtract 4 from it or something like that. Okay, so look at these binomials as one entire term. Okay, so on the left-hand side, I'm going to multiply the top and bottom by x minus 1. Okay, the denominator of the right side. And then the right side, I'm going to multiply by the denominator of the left side, x plus 3. Okay. Now step number 4. Multiply numerators. Okay, so I'm going to multiply it out. So I end up with x squared minus x is, I'll talk about the over in just a second, over 6, 6x plus 3. Okay. Now on the bottom, don't FOIL it out, don't distribute, anything like that. I'm just going to show it on this problem, but from here on out, we won't have to show this one. If you notice, I have common denominators, right? So this is kind of what we were talking about above. Once I have the denominator the same, I can drop it, right? Because what my goal is to make the bottom the same and make the top the same. So right now, I already have the bottom the same, so I've achieved my goal. I don't have to keep dragging it along. Okay, so I'll kind of put a 5 here, but I'll say drop denominator and solve numerator. Okay, so I'm going to drop the denominator and I'm just going to solve the numerator. So remember, solve just means get it equal to 0. Maybe you have to factor it, that kind of fun stuff. Okay, so I'm going to move everything to the left side. So minus 6x, and then minus 3 and minus a 3 here. So I get x squared minus 7x minus 3 is equal to 0. I did something wrong here. Oh, way back there. I was thinking this is not factorable. Okay, sorry, let's go back, retrace your steps. Believe it or not, 6 times 3 is not 3. So this guy should be 18. I apologize. Okay, so we'll go back and change these guys. Okay, go back and change them, please. Sorry about that. Cool. So we've got that that trinomial now. So in order to solve it, I've got to factor it. So I'm going to factor it now. So it would factor out to be x minus 9, x plus 2. Okay, and both of those guys are equal to 0. So if I set that guy equal to 0, the x minus 9, I would come out to be x is equal to 9. If I set the x plus 2 equal to 0 and solve, I would get negative 2. Okay, and so your last, very, very last step is to check. Sorry, I'll put maybe look at denominator. Okay, so kind of a check. Okay, you really don't have to do any work, but all you're going to do is you're going to look here. Okay, so look up there and see, do I have any answers that I've already told myself I can't have? So if I look, my answers were 9 and negative 2, and you told me that I can't have negative 3 and 1. So they don't match at all, so therefore those two guys are my solutions. Okay. So definitely a process here, but once you've done a few examples, you'll get more and more comfortable with it. Okay, so number 2. Okay. A few of you might ask, okay, well, since it's one fraction and one fraction, can't I just cross multiply? Yeah, you totally can, okay? But I'm doing this process just so that when we get to something like number 4 and 5 below, which should be number 3 and 4, that they make sense, that we're able to work those guys, okay? So number 1, factor if needed. Nice, I don't need a factor. Number 2, grab your domain. I'm going to put it over here. So my domain restrictions is if I solve the denominator there, that would be negative 4. And then on the right-hand side, I get negative 9. Okay, so those are my domain restrictions. Those are the values I cannot have. Now, multiply the fractions by the opposing denominator. Okay, so I'm going to multiply both this side by x plus 9. And then this side by x plus 4. Sorry, that one's hard to read. X plus 9. Okay, and so now the next one, I'm going to kind of combine 4 and 5 together. Okay, so I'm going to kind of put these guys together. So I'm going to multiply the numerators, and I know once I've multiplied each other's denominators that the denominators are going to match each other. So I can drop them at the same time. Okay, so right here, what I'm going to do is I'm going to multiply the numerators, so x plus 9, x minus 1. And then this numerator over here, x plus 3, x plus 4. Cool. Now I'm dropping the denominators because I know they're going to match. I'm going to have an x plus 9 and an x plus 4, and then an x plus 9 and an x plus 4. So I know they match each other, so I can drop them. So now here, this is all the second portion of 5 is solving the numerator. Okay, so this is where most of your work's going to come in. So distribute in, so we get x squared minus x plus 9x minus 9. And then over here, x squared plus 4x. And then this side plus 3x plus 12. Okay, so clean it up as much as you can on both sides. So this is x squared, this becomes a plus 8x minus 9. And then over here, we've got x squared plus 7x plus 12. Now, the thing that you love about these, even though it's a little bit harder than the other side to maybe multiply this out, if you notice, both sides now have an x squared. So I get to cancel them out. Okay, so those x squareds are gone because they match each other on opposite sides. Now, I'm just going to solve for the x. So I'm going to subtract the x over. you guys are super smarty pants, so I'm bringing the x over this side, so I'm going to bring the number over to the other side. So this becomes x is equal to, check it out, what's that, like a 21-ish? Now do a quick look here. Is my answer any of the two, in this case, two numbers that I cannot have? So I cannot have -4 and -9. I got positive 21. So those don't match at all. So wha-bam, there's my answer. Okay. Cool. Okay, number 4. We got a few more, 6 more. Okay, so this one here, this is where we get into that fact that we can no longer cross multiply. Okay, we have 2 fractions on the left side, 1 on the right. So we, because of the 2 fractions on the right, on the left, we cannot, we cannot do the cross multiply. But what we can do is go through and see how can I make each denominator match each other. Okay, so this denominator has an x, this one has a 4, and this one has an x. What I always say is, what is this guy missing that either of these two guys have? Well, he's missing a 4, so I definitely need to multiply the whole fraction by 4. And then here, it's 4 over 4. Okay, but I start getting lazy. And then it has an x. I already have an x, so I don't need to re-multiply it by x because it's already there. Now, if I look at this guy, he is missing the x portion of it, right? So I need an x on top and bottom. And then again, this guy right here is missing the 4. So he needs to have the 4. Now, if you look at all of the denominators, we've got 4x here, we've got 4x here, and we've got 4x there. Okay, so now they all match. So let's grab our domain before we forget. So our domain cannot equal. The nice thing here is the only variable you have is just straight up x. So that would be 0. Cannot have a 0. Okay. So I'm going to multiply the numerators, okay, individually. So I multiply that guy and I get 20. I multiply this guy and get 7x. And then equals, and I multiply these two, I get -36. Cool. I'm going to drop the denominators because they all match now, okay, and then just solve the numerator. Okay, so now we minus 20, so 7x is equal to -56. Okay, divide by 7. So x is equal to -8. Do a quick look here. They don't match each other. Oop, look. They don't match each other, so therefore I get to keep my answer. Cool, so that was a kind of a nice one. Okay, now there's a couple tricky things on number 5. So if you look, the only difference, remember I want you guys, whenever it's a binomial, to think of it as kind of one term. I unfortunately can't subtract 6 from here or make this into a +3 or anything like that. I have to multiply it by the entire term. So this guy has an x plus 3. Those two have an x minus 3. So he's missing an x minus 3. This guy's missing the x plus 3. And this guy's missing the x plus 3. Okay. I'm going to write it down here just because I ran out of space over there. But my domain restrictions, remember, grab this before you do any of the work behind it. So this portion right there would give me an x value of -3. And this portion right here would give me a +3. And this one would also give me a +3, so I don't need to repeat myself. Okay, so this first one here, I'm solving the numerator. So I'm distributing that 1 into both of them. Kind of makes my life easy, x minus 3. Now this next portion, I always recommend when you have a minus, we always get tripped up by this minus, right? So right here. So what I would recommend is make this guy a plus and then make it a -8. Okay. It's the same exact thing, but it's a lot easier for us to see. So now what I'm doing is I'm distributing that -8 into both terms. So now I have -8x minus 24. And then distribute this in here. So this would be 2x plus 6. Cool. Now clean up as much as you can. So over here I have an x and a -8, so -7x. And I have a -3 and a -24, so -27x. Now it doesn't really matter which way you bring which ones. I try to keep the x positive if possible. So I would add the 7x to the right hand side. Right, so that would give me 9x. And then I would also move, again, you guys are smarty pants, we can move the 6 at the same time. So -6, -6. So that's going to give me -33. Okay. Now divide by the 9. So I can switch it around now. So if we want x is equal to -33 over 9, which, believe it or not, 3 will go into both of them. So we could do -11 over 3. Okay, so that's my x value. Do a quick check. Nope, they don't match each other, so I get to keep them. Okay. I promise I'll have an example where we don't, where they don't match. Okay, or sorry, where they do match, where we can cancel them out. Cool. These next two, we actually have to take advantage, or sorry, actually these next 4, we do have to take advantage of step number 1. Okay, so factoring the denominator if possible. Okay, so again, we're not going to be super cruel and have you have 50 different factors. So if you look here on number 6, the first fraction, don't need to factor it. Second fraction, I might do this just to make sure that I don't forget that. And then this third fraction, holy smokes, I can factor that, right? So factor it, I'll give you a little hint. Usually it's probably factors that you've already been given, okay? At least in this class, okay? So it's x plus 1, x minus 2. Use that as a starting point, right? So if I multiply this x squared, that works. Or multiply the last, -2, that works. And then if I was to get the outside and the inside of FOIL, that would give me -2x, and this would give me 1x. So those combined would give me that guy there. Okay, perfect. It does actually work, okay? So use these guys as guides, but don't just assume that that's the right answer, okay? So now as I go through this, if you look at my first fraction, he's missing, between all of them, he's missing the x minus 2. So I want to multiply this guy by x minus 2. The middle one is missing an x plus 1. Excuse me. Missing an x plus 1. And the nice thing is that last guy, he's got everything, right? He's got the x plus 1 and the x minus 2. So he's done, right? And so now I can drop my denominators and multiply my numerators. So this guy with the 1 makes my life easy. We've got x minus 2. Now we've distributed in the -8. So that's going to be -8x minus 8. And the cool thing on the right side, I didn't have to multiply him by anything, so he just stays at 2. Cool. Clean up the left-hand side. So I get -7x minus 10 equals 2. So now, since I am just solving for the x, I want to get everyone away from him. So plus the 10, plus the 10. So -7x. Oh boy, I forgot the domain. Okay, very common. I try as hard as I can, but always get that domain first. Okay, so the domain here cannot equal, thanks to this guy, -1. And thanks to this guy, +2. Okay, these guys would actually be the same thing, but I don't need to write it an extra time. So there's my domain. Okay, sorry. Now let's jump back to solving. So I divide by -7. So x cannot equal -12 over 7. We do a quick look. It doesn't match either of the two. So wha-bam. That's our answer. Cool. We'll do a couple more here, and then I guess 3 more, and then we will be done. Okay. So now number 7, same idea, but this guy can be factored. This is a perfect square, so this is going to be x plus 4, x minus 4. Go through each one, grab your domain, so I don't forget. So my domain, x cannot equal, we've got a plus and a minus 4. Okay, from both of the two signs there. Now this guy has everything that the rest of the two have on the left-hand side. The middle guy, he's missing a x minus 4, and the last one is missing an x plus 4. Cool. So now we have common denominators, so we can drop them. On the left-hand side, we didn't do anything to that 7x squared, so we can keep that value. Now here I need to distribute in that 3x. So I get 3x squared minus 12x. And then the last one I need to distribute in the 4x. So I get plus 4x squared plus 16x. Okay, clean up that right-hand side. So we have 7x squared is equal to 7x squared. What? And then this guy right here. So negative 12x plus 16x would give me positive 4x. Now again, the nice thing is we have an x on each side. Maybe I'll actually show the step on this guy just so we know what's going on over here. So if you have 7x squareds and I take away 7x squareds from you, you have nothing left. Okay, and so 0 is equal to 4x. And then divide by 4. Now this, I told you we really don't want 0 in the denominator, but 0 in the numerator is okay. If you plug this into your calculator, you'll see 0 divided by 4 just comes out to be 0. Okay. And so x is equal to 0. We do a quick check over here. We don't have any of our domain restrictions, so we can keep all of our answers, which in this case is just 0. Okay. All right, last two. So here, factor if needed. Don't need to factor the first one. Don't need to factor the second one. The third one does, once you've checked it, it does factor out to be x plus 3x minus 4. Now go through, multiply this guy. Ooh, see, I keep forgetting now. I'm getting too excited. Cannot equal negative 3 from that guy and positive 4 from that factor. So that's my domain restrictions. So now multiply this first fraction by the x minus 4. The second one by x plus 3. And the third fraction here, we don't need it because they have both factors. Cool. Okay, so drop the denominator, multiply this guy by both of them. So 2x squared minus 8x. Multiply this 3x by both of them. We have 3x squared plus 9x. And then the last one, we didn't multiply it by anything. So we have 5x squared minus 7x. We just keep exactly what it says. Clean up the left-hand side. Well, bam, well, bam. We've got 5x squared. We got some x's here. So plus x is equal to 5x squared minus 7x plus 2. Now, if you notice, 5x on both sides, so adios, mi amigo. I'm going to add this 7x to the other side to bring it with the other x. So we have 8x is equal to 2. Divide by 8. So x is equal to 1/4. Do a quick check there. I don't have any of my restrictions, so I'm good to go. Cool. And then this very final one, hopefully this one has a matching domain restriction. So let's check it out. First one, I can't factor. Second one, I'm going to definitely change this guy. This is a perfect square. What do you know? X plus 2x minus 2. Kind of looks like the other two factors around it. And then the last one I cannot factor. Okay? So let's grab our domain restrictions. So x cannot equal plus and minus 2. So on the left here, the x plus 2, we're missing the x minus 2. This one, we're not missing anything in the middle fraction. And then the right fraction, we're missing the x plus 2. I have common denominators now, so I can drop those and just distribute in. So I've got x squared minus 2x. Now this 8, I didn't have to do anything with, which is nice. So minus 8. And then on this side, distribute in. Okay, so this becomes 2x plus 4. Unfortunately, in the problems before, we've been crossing out that x squared a lot, but unfortunately it doesn't cross out here, so I've just got to move everything from one side to another and solve it out. So x squared, these guys don't even cancel. Nothing cancels this time. We got our trinomial. In order to solve it, we've got to factor. So this becomes something like an x minus 6 and an x plus 2. And then we solve it out, so the left factor gives me a positive 6, and the right factor gives me a negative 2. Now before boxing your answer, take a quick look, quick gander. It says I cannot have positive or negative 2. Oh no! I've got negative 2, so all that means is I can't have that guy. So I just cross it out. The only thing, so my only answer that works is x is equal to 6. I hope you enjoyed it. Tell a friend, watch it again. We'll see you guys in class.